welcome to the Geology Today show. Today we are in the northeast corner of Yellowstone. We will go to Specimen Ridge, we will encounter petrified forests, and we will visit the Yellowstone Grand Canyon.
Here we see the yak in action. Look at his mighty antler. He approaches.
Crikey! Look at the size of this rock. Where could it have come from?
These rocks were deposited here by glacier.
In our last scene, we saw a few scattered boulders, which were the remains of glaciers. However, up here we see many rocks, which are all very similar, and they were left by lava flow and other lava debris.
Here we have an example of a petrified tree. Let's take a closer look. About 55 million years ago, there's lava flow that came over to this area, and it took, if you can see here, you can see the rings of the tree, and what happened was there's a lot of silica in the lava and it replaced the carbon.
Here we have a rock by which we can characterize how long this magma was in its magma chamber. This magma we see here, it was in the magma chamber only for a very short period of time, because as we look at these minerals under a microscope, we can see that they have 90-degree cleavages, which means that it's pyroxene. And pyroxene is a very lowly evolved mineral, which means that this rock was in a magma chamber for much less time than the rocks we have seen on other days. This show is brought to you by Delta Blanket. Perfect for use as a cape,
Or as a skirt.
or even as a blanket. Remember to inquire about a Delta blanket on your next Delta Airlines flight.
Here we have two wonderful species of rock. On the bottom is a flow deposit of sedimentary and volcanic rock. And on the top we have a lovely volcanic flow.
This is a petrified forest, and you can see down here we have a couple different layers. The first one is, if you can see, right far down below, and then we have some more up here, and what this means is that there are different, these come from different lava flows, so one came, covered and petrified the wood, and then there's more trees that grew on top. And then if you look up here, we have the most recent and biggest tree, and you can see the roots up here, which is very, very neat. And one reason that it's bigger is because it had more time to grow before the lava flow came.
Also was wir hier sehen, ist, dass das Lava tatsächlich so schnell alles präserviert, dass tatsächlich auch Blätter mit allen Venen und so noch da zu sehen sind. Das ist wahrscheinlich ein Lindenblatt.
And here we see the herd of bison grazing. Look at them munching on their food.
Here we are coming down into Yellowstone Grand Canyon. It is 1,000 feet deep and 6,000 feet wide. Here we see another species of petrified tree. So here you see the different deposits that Yellowstone Grand Canyon was made of. On the top you see there are very distinct basalt structures. That is a very active lava flow. Beneath that there is a kind of matrix incorporating different kinds of stones, and even lower you will see that it reverts to volcanic stone.
Here at the Grand Canyon we have some what looks like white and what we would think might be siliceous sinter, but it's actually hydrothermically altered rock. And you can also see little hot springs, and when the river floods they actually get covered by that, and they alter about every year.
This is a bison. This is a grizzly bear. And this is a raven.
And we're back. We are at the falls of Yellowstone Grand Canyon. And as you can see, the river here has eroded the rock and created a V shape.
It created such a V shape because the rock has been hydrothermally altered. It's rhyolite, and which makes it softer and easier for the river to cut through. So it has a very deep canyon. And also you can see many colors because of the oxidation of different metals in the rock.
The transition metals.
This is your host, the Yaki Sack. Thank you for watching Geology Today.
Geology rocks! That is a melange of sedimentary and
Or even as a blanket. No, it wasn't. Let's do it again.